Page 18 have some highlighters. You know the drill. I'm gonna have mine ready to go here. Okay. Recall that sinusoidal functions are periodic and therefore apply to scenarios where patterns repeat. For example, the height of a seat on a Ferris wheel. I really don't like Ferris wheels, guys. So my boys always want me to go on it. And I always tell them, don't move, don't move, don't move, don't shake it. Like this? Anyways. I shouldn't be scared of heights, right? Because I'm tall, but I am. No Ferris wheel for me if I had the choice. Anyways, average temperature for a full year, right? So if you were to plot the average monthly temperature for any particular year, you would have a cyclical periodic function. The time or depth of the ocean tide, etc. It could also be a rock getting stuck in a tire. And if you were to plot the height of that rock over time, it would also be periodic. So go ahead. Spring, like if you in physics have done any experiments with springs, you pull them down and you let go, right? The shocks of a car, stuff like that, it would be sinusoidal. The temperature in this room, if you set the temperature in your house to, like, let's say 22 degrees Celsius, do you think it stays exactly perfectly at 22? No. The thermostat has a little bit of a leeway. It will actually heat the house probably a little bit above 22, right? It will work, heat it, just above 22, turn off. And then the temperature will drop below 22, and then it will turn on again, heat it up, it cools off, it heats up, right? So it's actually a temperature in any room, in a fridge, anything like that, it's gonna fluctuate. That's why you have freezer bite. If you open your freezer too long, right, it warms up in there, you close it, you do that same over and over again, that's when you have freezer bite, because things like warm up, freeze, warm up, freeze. That's what happens, right? So that's why the longer you have something in the freezer, the bigger the chance of that food or wheat or whatever having freezer bite, right? All right, sinusoidals involving a wheel, that's important for you to know. So obviously it will look like this. A would be the amplitude, but in particular the radius. When it's a wheel, A in that particular scenario, right, A is the amplitude, would actually be the radius of the wheel. Okay? Therefore, wouldn't it stand to reason that the diameter would just be 2 times A, 2 times the amplitude, right? And obviously the period, therefore, would actually be 2 pi r. Remember, 2 pi r is what for us in the circle world? 2 pi r starts with a C. Circumference. Yeah, circumference. So, right, if you have a circle, this would be r, and in the sinusoidal world, it would be amplitude as well. Okay, and circumference, right, that's C. C is equal to 2 pi r, but in the sinusoidal world, it's 2 pi a, right? So it's the same thing, but we're now replacing radius with amplitude, okay? So if you think of the graph that I have here, I'm trying to give you a visual here, okay? So obviously this here is the radius. I'm going to highlight that first. If this is your tire, right, that would be the radius or amplitude. Same thing. That would be radius and amplitude. So if you think of, you always have to start with a particular point. So let's say we start, there's a rock or something stuck at the top of the tire. As time goes by, if this starts spinning, where would this rock start going? It would start moving this way, end up there, it would keep moving, end up there. It would keep moving, end up here. I'm kind of using the vertical lines to help me out, right? And then it would keep moving, and that would be a full rotation when it comes back to where it started. Okay, so there you have your sinusoidal. I don't know if you can see it. So this is what would happen if you graph the height over time. Okay, let's put time here. Time is the x-axis in this case, and if you had the y-axis here, this would be height in whatever. It could be feet, it could be whatever, right? So you can see that if this starts spinning, it would be cyclical, it would be periodic, it would continue over and over. Okay, so you have your amplitude here, you have your amplitude there, with radius, amplitude, whatever. And you'd have to agree that from here to here, by definition, that is a period, right? But what else is it when we look at the tire? From here to here, what can we say about that tire in terms of the rotation? If you start at the top, move down, and then are back up, how many revolutions of the tire? One full revolution, right? So I want you to see the relationship between a period and a wheel and how they are related. The terms are based, we're talking about the same thing, it's just wheel and the sinusoidal in general. So period, one period is equal to one revolution. And I want you to know that one revolution would be 2 pi amplitude. Okay, remember that. The distance you traveled from here to here, imagine me cutting this wheel right here and putting a string around it, cutting it and spreading it out, right? Essentially, you would figure out what distance has been traveled in one revolution, right? The bigger the tire, the more of a distance you will have traveled in one full revolution. I will tell you this here on page 18, right? Note the period of one revolution could represent distance or time elapsed. Okay, so it depends on the scenario. Is it time, or is the x-axis representing distance traveled? So you got to make sure you just keep that in mind. Okay? Okay. If a sinusoidal function, so this is kind of getting back to the symmetry of a periodic function. If a sinusoidal function has a minimum of 2.8 and a maximum of 512, determine the midline, the amplitude, and the period. I want you to add this because it's important. Assume they are consecutive. Okay, so we're assuming they're right next to each other, these 2 points that we were just told about. Okay. So how would you figure out the midline? The y, it's really the equation of the midline. Y mid would be max plus min divided by 2, correct? And that's 20 divided by 2, which is just 10. No problem there. What about the amplitude? Amplitude would be the max. What's the equation again? Max minus min divided by 2. 12 minus 8 is 4. Divided by 2 is just 2. So that's your amplitude. No big deal there. But what about the period? This is where you need to envision what's happening here. There's a min of 2.8. So I'm going to assume that the min is right here, and that's 2.8, right? And then we're given the max, which is somewhere up here. That max is 512. So you have to assume that the sine wave comes through the min, goes through the max, and that's all we're given, right? Min and max. But what do we know about the symmetry of the parabola? We know that. Are we seeing a full period right here? From the min to the max, that is not a full period because we know this thing comes back down. And it's only here, right, when you get to here that you have your full period, right? The distance from here to here. Okay? So this is given. This is all I have, though. I have half of a period there. And really, all you need to do here is you just need to use the period like this, where you go 2 times 5 minus 2. Right? Because you know that it's 3 units from here to here. It'll be another 3 units from there to there. We know that these are the same. So period would be 2 times 3, which is 6 units. It's 3 here, it's another 3 there. So we can actually now come up with this point, but we won't because they just ask us for the period. So when you have something like this, you just need to remember you're given half, right? From a min to a max, that's just half of a cycle. Just multiply the difference in the horizontal, right? Just multiply it by 2. For this, because when you're finding the mid, you're finding the average between the max and the min, right? So you would add these and find the middle like this. For the amplitude is if you have your sine wave, amplitude measures the distance from the top to the mid or from the min to the mid, like that's what we're finding here. The distance, this is amplitude here, right? So you go max minus min. The minus is the difference, right? Like this one you would subtract, here you add. Does that make sense? Okay. All right, you're with me, right? On a Monday. Okay, let's do a word problem here. I'm just gonna get it started at least. I don't think this will happen very often, but there was one provincial exam where this happened and it threw everybody out. It threw everybody out. Like, what is this? Right? Like, we've never had this before. And you cannot even type that in using your calculator. So that threw students off even more, right? They're like, right, as soon as you start typing sine, it doesn't allow you to put a value between sine and the bracket. So this was a problem. So I'm just going to throw that in here. So if it ever happens, you're prepared. So all you need to do here is take the 0.5 and multiply it out like that, right? Just multiply it, distribute it to this bracket that's right behind it. So it's just half times this, half times that, And so this is what it looks like. The good thing was the province would take off one mark, but you still got all the other marks afterwards, even if you entered the wrong equation. Right? So this ends up being 1.57075 t, and I use 4 to 5 decimals when I write that one down because I want my period to be a whole number, and oftentimes it just means having more decimals there. Okay, so that's when you distribute that, that's what you get. Use this one, right? Use this equation. We forget about this one now, okay? We distribute it and you get half of, right, these two numbers there. So let's answer the questions here. You got to understand that there's a wheel involved. It's really important that you understand that one, right? And there's height, right, and time in minutes, right? So we know that what our x and y values represent, right? So we've got time and height. Every single point on this sine wave will be that. Determine the diameter of the wheel. Okay, you know that the diameter is 2 times amplitude. Okay, it's 2 times the amplitude because amplitude is the radius. So 2 times, so this would be 2 times what? What's the amplitude? It's 20, right from the equation. So that's 40, and we are in feet, right? So you got to understand that you need to add the units there. Don't lose marks for units, guys. Just don't. If it's a word problem, there will be a unit attached to it. Right? How high above the ground is Tom at the lowest and highest point? Explain why this might be the case. So the highest is really the max, right? So we're going to go 25 plus 20. That's 45 feet. And the lowest, and you're like, Mr. Anderson, can I just type this into my calculator and figure out the max and the min? Yeah, you can. I think it takes too long, but sure. 5 feet. So it's a Ferris wheel. So why do you think it's like this doesn't quite touch the ground? Right? Like how are you going to get on it? Like that's what it's explained this basically. Right? So if you make an arrow to that, right? There's probably a ramp, right? A ramp leading up to the Ferris wheel. Right? And it's probably to protect people, right? Like as it's spinning, right, that the feet don't like get caught on the ground or something like that. But there it is. How long does it take to complete a complete revolution? What do we normally call this? Let's answer this first. This is the period. Yeah, we know that as the period. Okay. You know what? Horizontal. It's really the horizontal change from max to max or min to min. That's really what the period is. It doesn't care what x is. It just that's how you would find the period. It could be time in seconds, minutes, hours, days. It could be the distance, right? So how long does it take to make a complete revolution? I'm going to use this. Period is 2 pi divided by, don't use the original, we're going to use this one, 1.57075. And I'm just going to give you the answer. It's 4 minutes. You just round to 2 decimals. Whatever happens, happens, right? So watch this. 2 pi divided by 1.57075. Houston. Did I type it in wrong? Yes, I did. There. It's 4. See? If you round it to 2 decimals, it's 4. And what is time in? It's in minutes. And it's almost quitting time. So yeah, we're going to quit right here. This is what I'm going to say. I'm not going to assign word problems, but I will strongly recommend you go back. I assigned a bunch of graphing questions, right? Try at least 2, not just 1. Try at least 2 more for tomorrow, because I will most likely AC you on that, all right? And so just go back to previous pages. The answer keys are posted, right? Page 15, 16, they're all up there.